So, hello students, and sorry for being late. We are joining almost an hour late. It's 4:15 already, but I had some technical issues with my work, and I was also preparing for the class. And I think today's class will be a short class. We'll try to wrap up with all these problem solving sessions. Thank you for staying around here. I know the population is thin today, but then uh, we will try to cover up all topics as well. And for your instruction, that this is a recorded lecture, and the recordings of this class will be available on YouTube. So those who have joined for the live class, please ask your friends if they are around. The class is still on, and we will try to finish by 5 or just a little bit extra time. Sorry, apologies from my side for taking up your time, but I had to read well and prepare for these lectures. So we are here for solving lecture week 5 related problems, which is forest surveying. So where Professor Ankur Avadhia, who is the instructor for this course at IIT Kanpur, he has taught about all the classical surveying methods, the photogrammetry and LiDAR. These are the three lectures that we are going to cover in this module, and as well as all the doubts that you have regarding these lectures. सो अगेन आई विल बी इन्फॉर्मिंग, मैं आपका सबको बताना चाहूँगा, अगर आपके दोस्त या क्लासमेट्स आसपास हैं या आप उनको बोल सकते हैं कि इस क्लास को ज्वाइन करने के लिए। मैं माफ़ी चाहता हूँ कि मैं लेट ज्वाइन किया, क्योंकि मैं अपना प्रेजेंटेशन और कंप्यूटर्स बना रहा था। मेरे कंप्यूटर में कुछ प्रॉब्लम था, इसलिए मैं नहीं ज्वाइन कर पा रहा था। बट वी विल स्टिल होल्ड दिस क्लास। इफ़ नॉट, किसी भी दिन अगर मुझे क्लास नहीं लेना हुआ या फिर ये हुआ, तो मैं आपको प्रायर इन्फॉर्म कर दूंगा, एंड वी विल शिफ्ट दिस क्लास टू सम अदर वर्किंग डे, सो दैट आपको ज्वाइन करने में प्रॉब्लम ना हो। लेट्स से अगर मैं सैटरडे अवेलेबल नहीं हूँ, मैं कहीं और या तो ट्रैवल कर रहा हूँ या फिर मुझे कुछ काम आ गया है, देन वी विल शिफ्ट दिस क्लास टू सम अदर डे, लेट्स से संडे और मंडे और ट्यूसडे, डिपेंडिंग ऑन द कन्वीनियंस। सेम टाइम पे रखेंगे, so that people can join and clear their doubts. And always there is the second there is another TA for this course who is from IIC, so you should also attend their classes as well as mine, whichever you like, or maybe both. Okay, so all those students जिन्होंने जिन्होंने पहली बार इस क्लास को ज्वाइन किया है, so मैं जनरल सेट ऑफ इंस्ट्रक्शंस बता देता हूँ. सो दिस इज़ अ प्रॉब्लम सॉल्विंग सेशन, एंड मेरा फॉर्मेट ऐसा होता है दैट आई हैव प्रिपेयर्ड 10 मल्टीपल चॉइस क्वेश्चन फ्रॉम प्रीवियस ईयर असाइनमेंट्स, जो कि विच आर एग्जाम्पल क्वेश्चंस फ्रॉम दीज लेक्चर्स. तो टुडे वी आर सॉल्विंग वीक 5 ऑफ द लेक्चर्स, फॉरेस्ट एंड मैनेजमेंट वीक 5. सो आई होप ऑल ऑफ यू हैव गॉन थ्रू दीज लेक्चर्स. आपने लेक्चर्स सब पढ़े होंगे जहाँ पर ये करना होगा. Okay, there is a comment from Darshini, says please speak in English. Yeah, Darshini, I was speaking in mix of Hindi and English because some of the students requested that they are not able to follow English so well, so that is why I switched to this. Otherwise I am totally comfortable in speaking with English. If others are okay with me speaking English, then I would totally conduct this assignment in English, because English is the official platform language. Are others okay if I speak in English? बीच बीच में अगर आपको कोई चीज़ समझ में नहीं आई, then I can tell you in Hindi. I think some others are facing problem if I speak or switch to Hindi. Okay, I'll try my best so that everyone can understand. So I was just briefing you about the instructions of this class, that this is a recorded class and the materials and the recordings will be available to you through the NPTEL guys. And so we will be having 10 multiple choice questions which are very similar to what you will be facing in your assignments and in your quizzes. And these are old course assignment problems. And through solving these questions, we are trying to attempt to understand, we are attempting to understand the concepts behind these questions. So हम एक एक question solve करते जाएंगे. We will solve each question and then try to understand the concept behind it. As simple as that. So I would request all of the participants to please mute yourselves and turn off your video chat. Let me be the only person who is speaking for smooth conduction of this session. You can communicate with me via the chat box. You can post your queries, your answers and any doubts that you have in your chat box. आप मुझे chat box से लिख के भेज सकते हैं, आपको जो भी भेजना है आप मुझसे chat box में बात कर सकते हैं. Okay, let's start the class. Let me present my screen. I hope you are able to see me clearly and hear my voice. मैं अपना अभी screen present करूँगा and then we will start this class. Okay. So is everyone able to see my screen? Is everyone able to see my screen and is everyone able to hear me? Can you see the slides changing? You can tell me in the chat box with a yes or just a like on this platform. Thanks. Thanks, Darshini. Okay. So once again, my name is Ashutosh Behra and I'm a teaching assistant at IIT. I am a PhD scholar at IIT Kanpur and teaching assistant for this course, Forests and Their Management. This course is taught by Professor Ankur Avadhya from IIT Kanpur. And myself, Ashutosh, I'm a PMRF scholar. So PMRFs have tied up with NPTEL to take teaching assistant classes and these problem solving sessions to help students learn better in their courses in distance learning. Okay. So this will be the order of the presentation. I have 10 multiple choice questions on the slides to which I will ask all of you guys to post your answers to these questions. आपको मुझे सही जवाब बताने होंगे. You post your answers in the options or in the comment box. I will check these answers and let you know what is the correct answer to the particular question. And then we will understand the concept behind why the correct answer is the correct answer. Okay? And in the process we will learn yeah, thank you. So as per the instruction, please mute yourselves and your video chat during this session. Communicate with me through the chat box so that we do not have any disturbance. Okay, so without wasting any further time, let us move to the first question. Question number 1. This sampling employs a simple rule of selecting every kth unit starting with a number chosen at random from 1 to k as a random start. Okay, so this is a sampling method in which every kth unit starting with a number chosen at random from 1 to k is chosen as a starting point. What is the sampling method we are talking about? ये कौन सा sampling है जो every kth unit को select करता है randomly from 1 to k and उसके interval को follow करता है? Option A, simple random sampling. Option B, systematic sampling. Option C, stratified sampling. Option D, multi-stage sampling. ओके, सो आपको क्वेश्चन दिखाई दे रहा है, मैंने आई रेड इट अलाउड. प्लीज पोस्ट योर आंसर्स in the chat box whatever you think is the correct answer. What is this sampling method in which we select every kth unit, and this selection is, the first selection is a random number between 1 and k, and then it reiterates or repeats in fixed intervals, selecting every kth unit starting with a number chosen at random from 1 to k as the random start. Okay, let's take 20 to 30 seconds and then I will reveal what is the correct answer to this question. I encourage all participants to please post your answer. आप लोग सब participate करिए and अपना answers post करिए. शर्माने की ज़रूरत नहीं है because you guys don't have to turn on your video chat or mic. You can just silently post your answers in the chat box. It's okay if your answer is correct or wrong, but we will find out what is the correct answer, and I will ensure that all of you understand the concept and we will move forward so that you don't make the same mistake twice. Okay, let me check the comment box if people have answered. Om says C, Rohan says C, Darshini says A, Rituraj C, and Swayam says C. Okay, any more answers? किसी और को आंसर देना है? Okay, let us look at this question. What is the correct answer? This sampling employs a simple rule of selecting every kth unit starting with a number chosen at random from 1 to k as a random start. And this is known as option B, systematic sampling. So this is called systematic sampling. It's not simple random sampling or it's not stratified sampling. This is systematic sampling. Okay? So all the answers in the chat box, B is the correct answer, not C or not A. Now let us understand what is systematic sampling and what are we talking about. क्या है ये systematic sampling? Systematic sampling in forest means selecting sample plots or trees at regular intervals across an area instead of choosing them randomly. So this was the catch or key point in the description. Sample employs simple rule of selecting every kth unit starting with a number chosen at random. So this k represents the interval. It means it is iterative या repeat पे हर k unit को हम चुनेंगे, but the number as a start is chosen random between 1 to k. So sampling the plots of trees at regular intervals across an area instead of choosing them randomly. If you choose them randomly, it is simple random sampling. But when you are choosing the intervals to be specific, the kth interval, it is systematic sampling. For example, in a forest, suppose there are 1,000 trees in a forest section where capital N equal to 1,000, total number of units or total number of trees, and we want to sample 100 trees in a sample unit. Small n equal to 100, which is this desired sample size. We cannot measure the total forest, but we can only measure a fraction of the forest or a unit, arbitrary unit of the forest, and then extrapolate it. So then we select the k, which is the interval, as the total number of units by desired sample size, which is 10. And now we have to select a random start point between 1 to 10. So if we, let's say, if we select 7 as our start point, then at every k interval, which is 7, 17, 27, 37, 47, this, and if we number the trees from 1 to 1,000, this is the interval we are going to study or sample the trees. The first sample will be tree number 7, the second sample will be tree number 17, number 27, number 37, number 47. Now if it was a simple random sampling, then it would have been 5 or 8, then tree number 22. So randomly pick up sampling units, you sample them or you survey them, and then you extrapolate what is the total population based on these. You take an average out of those random units, randomly sampled units, and then you extrapolate the total population level. So first we choose a random start, pick a random number between 1 and this k, which is the interval, sampling interval, and sample every kth unit. If k is equal to 5 and the random start is at 3, the example would be 3, 8, 13, 18, 23 and so on. Okay, and here is a comparison between different types of sampling. Random sampling, it is statistically sound, but random sampling does not work well in small areas. So where you pick random samples in a total plot area. Stratified random sampling, where you divide the total plot area into certain stratification. Let's say in a single forest area, you have a water body, you have a forest land, you have an agricultural land. Then you don't randomly sample the water body, agriculture and forest land and average them together. You have a stratification. You pick up random sample from a singular stratification. आप एक तरह के जगह के अंदर samples उठाते हो and then you average them out. That is stratified random sampling, which is all areas present in a forest. Hello. I would again please request all of the participants to please turn off your mic so that it's easier to conduct this class and for other students as well. Okay, so what is stratified random sampling? Stratified random sampling, you stratify the plot area or the area of your interest into certain classification, such as water bodies, such as grasslands and forest area, and then you pick random samples within a certain stratification. आप एक टाइप के stratification के अंदर कुछ random plots select करें and then you measure the your sample. So it is representative for all areas, but a prior knowledge is required that what is the stratification of that area. Now this is systematic sampling, in which you have uniform spread. In every kth interval you do a sampling, but you start with a random number between 1 to k and then you average it out. This is systematic sampling that we just saw. And then cluster sampling is cost efficient, but you are dependent on making these clusters. Okay, so I hope it was clear to the students that sampling with a fixed interval, starting at a random number and sampling at a fixed kth interval, is systematic sampling. While when you know the stratification of the area, that is stratified random sampling, and random sampling picks up just sample or plots in a random manner and then averages it out. Is everyone able to understand? क्या सबको समझ में आया? If yes, then type yes in the chat box or give me a like or a thumbs up. Very good. Okay, let's move to the next question. Question number 2. IMU stands for dash. IMU stands for dash. Option A, imperial metering unit. Option B, inertial metering unit. Option C, imperial measurement unit. Option D, inertial measurement unit. Now what is this IMU? Where have you encountered this term? And what is its meaning? What does it stand for? Hint, it is a feature involved in LiDAR imaging or LiDAR survey. I have given you the hint. Now recall the answer and tell me. Post your answers in the chat box. Let's take 30 seconds to collect some answers and I will reveal what is the correct answer. Okay, let's look at what are the answers in the chat box. So Darshini has answered option D, Om, option D. Rituraj, Rohan, Swayam, everyone is saying option D. Okay. So let's look at what is the correct answer to this question. IMU stands for inertial measurement unit. So option D is the correct answer. Well done, all of you have given the correct answer. So IMU is standing for inertial measurement unit. Now let's look at what is IMU and what is its role in LiDAR imaging. IMU stands for inertial measurement unit. It is a sensor that measures the motion and orientation of the LiDAR sensor while it is moving. Now LiDAR is the imaging or the surveying pattern in which the aeroplane or the aircraft, airborne LiDAR, there are aerial platforms which cameras and laser fixed. Now they have also the first parameter of the aircraft is the position of the aircraft, which is determined by GPS and IMU. DGPS and IMU, as mentioned in the lecture by Professor Avadhya very nicely. So IMU is the sensor that measures the tilt of the plane to determine the correct position of the plane and the angle of the laser it is shooting to survey the topographical surface of the area. So as here, this plane is equipped with GPS positioning system to locate its location and an IMU which measures its tilt and axis tilt, so that we have a precise measurement of its location in the LiDAR platform. Now why IMU is important in LiDAR? When a LiDAR is mounted on a drone or an aircraft or a vehicle or a backpack system, that platform is constantly moving and tilting. The IMU records how much it tilts, how fast it rotates and how it accelerates. So basically the IMU is a robotic or a sensor device which measures these three parameters, which is the roll of the aircraft, which is the yaw of the aircraft, which is spin like this, and the pitch of the aircraft in the three axes. This information is used to correct the LiDAR measurements. So the correct position of the airplane is determined by GPS and IMU, which is thus very important for precise measurements or scanning or survey of the topographical system. Is it clear to the students? You have answered all correctly, but did you understand what is an IMU and where is it used? Very nice. Okay, quickly moving on to question number 3. Dash is how close the measured values are to the correct value. Question number 3. Dash is how close the measured value are to the correct value. Option A, accuracy. Option B, precision. Option C, bias. Option D, variance. How close the measured values are to the true value or the correct value of the measurement. What is this called? I think this is an easy question for everyone. All of you must answer. Please post your answers in the chat box. In a matter of 30 seconds, I will reveal what is the correct answer to this question. And I'm hoping that all of you would give the correct answer. Okay, now let us take a look at the chat box and what people have answered. Darshini says A, Om says B, Swam A, Rohan B, Kurba says B. Okay, there is a confusion between A and B. Then we will understand it, what is accuracy and what is precision, and we will get this concept into our heads once and forever. Okay? Excuse me. So answer to question number 3, dash is how close the measured value are to the correct value. Correct answer is A, accuracy. Come on guys. Accuracy is how close the measured value is to the correct value. But precision is how close the measured values are within each other. That is precision. While accuracy is how close the measured value is to the correct value. Okay, now let us understand this with the definition and an example of the bullseye example, very famous and very easy to understand. So accuracy refers to how close a measurement is to the true or accepted value. If you hit near the bullseye, you are accurate. For example, if the actual weight of an object is 10 kilograms and you measure 9.9 kilograms, your measurement is accurate because it is very close to the true or accepted value or the real value or the correct value. How close the measured value is to the correct value. Now precision refers to how close repeated measurements are to each other. Precision is within all the measurements that you take. एक measurement दूसरे measurement से कितना मिलता जुलता है, that is precision. So if your shots land very close together, even if far from the bullseye, you are precise. For example, if you measure 8.5 kilograms, 8.6 kilograms, 8.5 kilograms, but the true value is 10 kilograms, your measurements are precise but not accurate. इसका मतलब ये जो तीन वैल्यूज़ है वो अपने आसपास कितने हैं, ये तो बहुत ही आसपास है, इसीलिए these values are precise. When the measured value, the repetitions of measured value or the number of measurements you took are close by or the difference between them is close by, that value is known to be precise, even if it is not accurate, which is close to the accepted value. So accuracy, close to the true value, precision, close to each other. Accuracy can be accurate but not precise. Precision, something can be precise but still not accurate. Accuracy is affected by systematic errors, such that errors that are present in the system or in the instrument or in the measurement criteria, while precision is affected by random errors. Okay, so this is a bullseye example of accuracy and precision. So if an archer or a shooter tries to aim to the bullseye of the target, so the bullseye of the target is the accurate value, while precision comes from the different number of shots the athlete takes. So this is an example of accurate and precise shots, where each of these shot is close to the accurate value, is close to the real value, that is why it is accurate, and each of these shots is also close to each other, that is why it is precise. Now this is an example of not accurate but precise. All four shots are close to each other, that means it is precise, but all these four shots are far away from the real value or the accepted value. That is why it is not accurate but precise. Here it is neither accurate nor precise. Sorry, here it is accurate but precise because these four of these are not precise because they are not close together. There are large differences lying between the values, but they are somewhat close to the bullseye. But these points here show that it is neither accurate nor precise. So the take home message is accuracy means how close it is to the real value, and precision is how close different measured values within each other. This is the major difference, close to the true value while close to each other. Is it clear to the students? क्या सबको समझ में आया? This is an easy concept but it can be confusing. If yes, then let me know in the comment box, or you can give me a like, or then we can move forward. Very nice. Okay, cool. So far so good. Let's move on to the fourth question. Fourth question, a list of sampling units is called dash. A list of sampling units is called dash. Option A, frame. Option B, window. Option C, sample. Option D, population. What is a list of sampling units called? Okay, post your answers in the comment box for me to read them, and let us take 30 seconds for everyone to post your answers, and I will read the answers and reveal what is the correct answer in some time. Okay. Okay, let us look at what are the answers in the comment box. I only see three answers: Darshini, Om, and Swayam. Option A. No more answers from others. Again, it's up to you guys. You guys want to participate or not, but participating is more fun and you would learn new things. And if you have any doubts or you want me to repeat any concept, you can let me know in the chat box. आप मुझे बता सकते हैं अगर आपको कोई कॉन्सेप्ट नहीं समझ में आ रहा है, if you want me to repeat any concept. Okay, now let us look at what is the correct answer to question number 4. A list of sampling units is called a frame. Option A, frame, is the correct answer. And all three of them have given the correct answer. Good job. So list of sampling units is what is known as frame. Now let us understand what is a population, what is a sampling frame, and what is a sample or a sample unit. Now population is the target population under study, or here is our forest. Sampling frame is a part of accessible target population and which is now comprised of sample, which are the actual units under study. So the sample units, sampling unit, are the areas or the patches of forest or land that we can actually count or measure, which many such sampling units consist of the sampling frame, now which can be extrapolated to the population. Now if we know the measurement or about the sample, we can extrapolate it to the sampling frame, which can further be estimated for the population. Sampling units in a forest are the specific measurable non-overlapping areas or points where data is collected. So this is the region where the data is actually collected, while the sampling frame is the total set of these potential identifiable units from which a sample is selected. So from where to select your sample, that is the sampling frame. So in a sampling frame there are multiple sampling units and sampling methods, which we just encountered in the previous question. And using such of these sampling methods, we select our sampling units. We actually measure our measurements or count in those sampling units while trying to cover most of the sampling frame. For example, you divide the forest map into 100 equal blocks. Let's consider this example. Let me turn on the pen and then we can see what is going on here. So let us consider an area of forest. So many trees here. So this is the population. Now if we divide the forest map into 100 equal blocks, let's say this is 100 equal blocks, each block is 1 hectare, so 100 hectares. Population 100 hectares. And we want to measure the size of this, or how many trees are there in 100 hectares. So what we will do, we'll divide this forest map into blocks. Like this, so that we can count easily. And each block, let's say we make a block of 1 hectare. Now these 100 blocks, roughly 100 blocks, form our sampling frame. So this is sampling frame. And we create our sampling frame as such that it extrapolates to the population. So sampling frame is a good sampling frame. It is very close if it is very close to the population. If such a sampling frame can cover whole 100 hectares, then that is a good sampling frame. The sampling frame, the complete list of all possible areas you can choose from. Now what is the list of all possible areas you can choose from? That is the sampling frame. So sampling frame is equal to 100 1 hectare blocks shown on this forest map. Now what is a sampling unit? Each of these grids, let's say this grid is a sampling unit. Now you cannot measure the whole sampling frame, but what you can do is you can select a sampling unit. Let's say there are 2 trees here. You count, you do the actual measurement here. In the sampling unit. So you actually measure in the sampling unit and simply multiply roughly it by 100, because you have 100 such sampling units to form one sampling frame. So now you choose randomly 10 blocks out of 100. Either we do random sampling or we do systematic sampling or strategic sampling. And each plot where you collect the data is a sampling unit. The sampling unit is the actual area where measurements are taken. So not just this, we measure many such sampling units like this, this one, let's say this one, and then average it out, average measurement, and you simply multiply by 100 because there are 100 sampling units forming this sampling frame, and then you get a rough estimate or survey of the whole sampling frame. Okay, is it easier to understand now? Did everyone understand? Very simple concept: sampling units, sampling frame, different methods of choosing our sampling units, and how to survey a large area very effectively. Okay, is it clear? Very nice. Okay, let's move on to the next question. Question number 5. The time of flight for LiDAR is 0.00001 second. Find the distance of the object from the instrument. Okay, so this is a calculation based question. The time of flight for LiDAR is 0.0001 second. What is the distance of the object from the instrument? So put your pen paper to work and post your answers in the chat box. Let us take a 30-second or a 1-minute time gap and I will reveal what is the correct answer. Okay, I think it is enough time for this question. Have people done their calculations? Let us find out in the chat box. Darshini says C, Om says C, Swam says B. Okay. Any more tries? Any more students coming up with calculation or tries? Come on guys, we are in the 5th question. I want all of you to participate so that you get a chance. Everyone gets a chance. Okay, I think it's enough time. Let us find out what is the correct answer. The time of flight for LiDAR is 0.0001 second. What is the distance of the object from the instrument? Correct answer is option C, 1500 meters. This is the correct answer. 1500 meters is the distance from the object to the LiDAR. Okay, so I think Darshini and Om has given the correct answer. I'm sorry Swam, but B is not the correct answer. Okay, let us understand what is LiDAR and how do we derive this formula, and then we put the formula for calculating the distance of the object into place. So let us consider our LiDAR here. This being the aeroplane. If you consider the aerial LiDAR, okay, I'm not so good at drawing in this, but can imagine. So in this LiDAR we are trying to measure or trying to see the topography of this surface, let's say this point, and we have our laser emitter and receiver complex here. The light falls like this and is received back by the receiver. Okay, so what is the question here? We have to find out what if this is the object O, and this is the LiDAR L. Okay, so then what is this distance of the object from the LiDAR? This is the question. What is D if we consider this D? Okay, so now what is the principle of LiDAR, or how is this method works? So from a LiDAR we have a laser source which will shoot monochromatic laser to the object, and the object will reflect back the laser to a detector or a receiver present on the aeroplane, and that is how we detect the signal back and we find out information about the object in return. Okay, so if we consider the laser light, so its velocity or speed can be written as C, which is equal to 3 into 10 power 8 meter per second. Okay, speed of the light, which is the laser velocity. So now the laser will shoot. So laser shoots. Laser hits the object O here, and then laser goes back to the receiver. Okay, so what is the distance traveled? Distance traveled by laser is equal to, so once it goes down, touches the object, then comes back, and we know this distance is D, so it is D for going down, D up plus D down is equal to, it's the same distance, so it is 2D. Now if the laser takes time t, the time elapsed t, then we can write, so if time elapsed is equal to t, so from when the laser shoots and then receives its signal back, if the time elapsed is t, then t can be written as, so speed is equal to distance by time, or time is equal to distance by speed. T can be the total distance traveled by laser by speed of laser. So T is equal to 2D by C. So now if we arrange this equation, we can get D is equal to c into t by 2. So this is the distance of object from the lidar. Okay, so this is the formula that we are going to use. So what we will do, now we know that d is equal to c into t by 2. Okay, so here the c is equal to 3 into 10 to the power 8 meter per second, and the time taken between the object is just given in the question, which is 0.0001 second, which is 0.00001 of a second, or we can write it as 1 into 1 2 3 4 10 to the power minus 4 seconds. Okay, now putting this together in the formula, d is equal to 3 into 10 power 8 into 1 into 10 power minus 4 by 2. So this and this becomes 4, so is equal to 3 by 2 into 10 power 4 is equal to 1.5 into 10 power 4. And if you remember this is meter per second into second. So this will be in meters, which is 1500. 1500 is it? Meters. 15,000. Sorry, I just made a mistake here, a zero mistake. If you just remove this is actually the other way around. It's 10 to the power minus 5, and then this will be minus 5. Let me just do this calculation again. This is minus 5, so this is cut, this is 3, so we get here we get here 3, this is 3, so answer is 1500 meters. So okay, is everyone able to understand that how we calculated the distance? And pretty easy if you remember just simple physics, that the distance traveled by the laser light is twice, once it travels 2, which is down, and then back up to the detection center. Okay, very good. Now let us move to the next question. Question number 6. Which of these is correct? Option A, you have to tell me which of these is the correct statement. Option A, plane surveying takes into account the true shape of the earth and is used for smaller areas less than 250 square kilometer. Option B, plane surveying takes into account the true shape of the earth and is used for larger areas greater than 250 square kilometers. Option C, geodetic surveying takes into account the true shape of the earth and is used for smaller areas less than 250 square kilometer. Or option D, geodetic surveying takes account the true shape of the earth and is used for larger areas greater than 250 square kilometers. Okay, 4 really close statements, but only one of them is correct. The hint is there in the options as well. These are the different types of surveying that one can do. It's a plane, either is a plane surveying or a geodetic surveying. Let us take some time, read all the options carefully and let me know what is the correct answer. Okay, I think it's time to reveal what is the correct answer. Let us look at all these options again. Which of these is correct? Plane surveying takes into account true shape of the earth. This is totally wrong because plane surveying assumes that the measurement of the earth will be in a single plane and it does not reflect the true shape of the earth. So that is why plane surveying is done less than 250 square kilometer. This statement is true, but it does not account the true shape of the earth. So first and second option are not possible. Then comes about geodetic survey. Geodetic survey takes into account the true shape of the earth, but it cannot be used for smaller areas which is less than 250 square kilometer. So therefore option D is the correct answer. Option D is the correct answer and Om and Swam have given correct answers. Very nice. Very good. So let us understand what is plane surveying and geodetic surveying. So when we are surveying a piece of forest or a land, we have to take into account, we have to take into account or we have to take into account that earth is spherical. Or earth is geoid. Geoid is the shape which is earth, so which is stout at equators and elongated at poles, and it's a three-dimensional elliptical body, so it is somewhat like this. So it's more sort of elongated at the poles, but it is stout at the equators. If you just right. So earth is a spherical surface. Now if we want to survey the earth surface, let's say this region, then what does plane surveying do? In plane surveying, and geodetic surveying, so geodetic surveying takes true form of the earth, which is aspherical, and it often involves angular measurements. Okay, so geodetic surveying takes the true form of the earth and it is spherical and angular measurements. It happens often greater than 250 square kilometers. While plane surveying depends on the fact that if you elongate this spherical surface of the earth into further small distances, then you can assume them to be nearly flat or planar. Now it is easier to survey this area or measure this area in a planar manner. And there is no angular measurements. And it does not take into account the true nature of the earth. That is why it is only valid in small patches which is less than 250 square kilometer. Okay, Now let us see the difference or definition difference between plane surveying and geodetic surveying. Earth surface is considered as a plane surface at short distances. At short distances where you can draw a tangent to the earth surface. The curvature of the earth is ignored. The line joining any two stations is considered as a straight line, and the triangle formed by any 3 points is considered as a plane. The angles of the triangle are considered to be plane angles and carried out for small area. So the method you use is you draw 3 points, 3 different points, and you consider it as a plane, and in a shorter patch of area where it is a straight line or the curvature is ignored. While in geodetic surveying, earth surface is considered as a curved surface, curvature is taken into account, line joining any two stations is considered as a curved line. It's not a straight line like two stations here and here. This is considered a straight line, while line joining any two stations is a curved line here. Like here and here. The angles of the triangle are considered to be spherical and carried out for large areas greater than 250 square kilometer. I hope it is very clear to the students the difference between geodetic and plane surveying, and what are the assumptions made in different kinds of surveying. Is it clear to the students? If yes, then we can move ahead. Please let me know with a yes or a like in the chat box. Okay, I think we should move forward to the next question. Question number 7. A sampling procedure such that each possible combination of sampling units out of the population has the same chance of being selected is referred to as dash. Now if you remember the different sampling methods that we saw in the first question itself, you can really give the answer to this one. A sampling procedure such that each possible combination of sampling units out of the population has the same chance of being selected, or it is random, or each individual has a random probability of getting selected. Now which of these is a sampling method? Option A, simple random sampling. Option B, systematic sampling. Option C, stratified sampling. Option D, multi-stage sampling. Please post your answers in the chat box, and I will reveal what is the correct answer. Okay, it's time to check what are the answers in the comment box. Om says option A, Swayam says option A. Okay, so this sampling procedure, which is ensuring that each possible combination of sampling units has the same chance of being selected, is called simple random sampling. Very good. Correct answer is option A. Om and Swayam have given the correct answer. Simple random sampling. Now what is simple random sampling? Simple random sampling is a method where each member of the population has an equal chance of being selected randomly. So being random means each member of the population has a equal chance of getting selected. So let us consider different individuals, different kind of individuals in a population. the black one, orange and the green one. Random sampling ensures that if you pick at random, each individual of the population will at least get represented once. And these are the methods that are used for simple random sampling, like lottery method, random number generator, random digit dialing, table of random numbers, and systematic random sampling. Okay, so you use a lottery method, you select a random number out of all the samples, and then you do the actual measurement. So in forestry, we choose a simple random sampling, choose any patch or plot of area randomly from 1 to 100 depending on the number of sampling units we have, and then we measure that area, we take average out of it, and that is known as the simple random sampling. So to do this, the procedure is to define the population, what is the area that we are trying to measure, decide on the sample size, what should be the sample size, whether we are going to measure 1 lakh trees or 10,000 trees, randomly select through a lottery or random number generator to which number of trees that you are going to, or which plot you are going to measure, and then collect data from the sample, average it out, and then extrapolate to the sample frame to know or to estimate what is the total amount of trees present in an area. This is called simple random sampling. The method is so random with a random number generator that each individual of a population at least gets one representation or equal representation randomly. Is it clear to the students? If yes, then let me know in the chat box or with a like, and we will move forward to the next question. Okay, really good. Here is question number 8. Frequency of flyovers is an indicator of dash. The frequency of flyovers is an indicator of dash. Option A, spatial resolution. Option B, temporal resolution. Option C, spectral resolution. Option D, radiometric resolution. Frequency of flyovers. Please post your answers in the chat box, and I will follow it up in a while and tell you what is the correct answer to this question. Okay, let us see what are the answers in the comment box. Om says B, Rohan B, Swayam says B. Okay, let us find out what is the correct answer. Frequency of flyovers is an indicator of temporal resolution. So option B is the correct answer. Om, Rohan and Swayam, very well done. So let us understand what is frequency of flyover and where is it applicable, and what does it mean when we say that it refers to temporal resolution. Now, frequency of flyover typically refers to temporal resolution, representing how often an area is scanned to update the 3D data, often spanning weeks, months and yearly intervals. So this is in context to LiDAR measurements. So in a LiDAR system, we have satellites. We have satellites in space, actually multiple or a group of satellites, fleet of satellites. Which does two things, actually help in GPS and also provides scans, or can aid aerial vehicles in scanning, in laser scanning. So suppose this is an object or a tree here, and this is our plane which is trying to scan it through the LiDAR. Now what do we mean by frequency of flyover? Like what is the frequency of this plane to fly over this same sample, this same sampling unit for the next time? The plane scans it. What is the time elapsed between the second scan and the first scan? This determines the frequency of flyover. How frequent the LiDAR system is flying over the sampling unit, that is known as the frequency of flyover. And this will give us a temporal resolution, because what is the reading that has changed between the time elapsed for this LiDAR plane to sample this unit. So let's say this plane is taking 3 days to come back to the same sampling unit and scan it again. So what is the updated forest area? If there was a wildfire which burned some forest, were the trees cut down, was the canopy lower? What is the updated forest area is what will be collected by this plane. Now if the frequency of flyover is increased, then the LiDAR will have higher resolution, temporal resolution, higher temporal resolution. How quickly it can sample the same place twice, so that any updates that are there cannot be missed. Understood? So this is what we refer to frequency of flyover, and what is the temporal resolution of the LiDAR image or LiDAR signal from the same sampling unit between the first and the second scan, and what is the updated data of the forest area that is being collected by the LiDAR system. Same for the satellites. If a satellite is scanning its GPS or using a system to precise imaging of the topography, then what is the time interval between the same satellite or the same system coming to the same place, and what is the frequency of interval? So that is known as the frequency of flyover, which provides temporal resolution. Is it clear to the students that what is the frequency of flyover and how a temporal resolution is obtained by the LiDAR imaging or LiDAR data from the same sample unit? Is it clear to the students? Please let me know with a like or a yes in the chat box, and then we can move forward. Very good. Now looking at question number 9, dash is how close the measured values are to each other. Now this should be an easy question. Dash is a measure of how close the measured values are to each other. Option A, accuracy. Option B, precision. Option C, bias. Option D, variance. How close the measured values are within each other. What is the measure of that? Is it accuracy, precision, bias, or variance? Okay, I don't think this should be a difficult question. Guys, please answer up. not much time we would take on this question. How close the measured values are to each other is known as option B, precision. Yes, Darshini, Rohan and Om have answered correctly. It's precision which tells us how close the measured values are to each other. How many times or what is the frequency of getting similar or accurate or similar values to each other is the high precision data. So again, using this bullet or bullseye example for understanding accuracy and precision. So low accuracy, low precision, this is the point where we would find accuracy. So if this point is of our interest, points which are more points closer to this point will indicate higher accuracy. Like this is a higher accuracy, and even this is high accuracy, because each of the point is close to this center point, the point of our interest. Now high precision would be when, irrespective of closeness to this point, whether these data points are close to each other. So this would be high precision and this would be high precision. Therefore this is low accuracy, low precision, high accuracy but low precision, because points are not close enough, because there is variability within each other. High accuracy, high precision, because it is close to the center point, as well as the points, data points are close to each other. While here we have high precision, but the accuracy is shifting a lot because the data point is so far away. Is it clear to the students? Very subtle but meaningful differences between accuracy and precision. Okay, coming on to the last question. Bathymetric LiDAR uses dash light. Bathymetric LiDAR uses which light? Option A, far infrared. Option B, near infrared. Option C, orange light. Option D, green light. What is bathymetric radar and which wavelength of light does it uses? Come on guys, this is the last question, and after this we are going to end the class. So show some participation and post your answers in the comment box. I will reveal the answer shortly. Okay, let us look at what is the correct answer. Bathymetric LiDAR uses option D, green light. And Om and Darshini have answered correctly. Option D, green light, is the correct answer. Now what is bathymetric LiDAR? So this is an example of LiDAR here, which is laser plus radar. We are using the principles of radar, but instead of sound waves we are applying laser, which is monochromatic. Now for a topographic or land surface, we need near infrared radar, near infrared light, near infrared. And bathymetric means underwater terrain. Here we need green light, green wavelength. Why so? Because green wavelength is the one which can penetrate the water and reach the bottom to find out the terrain. Whereas near infrared is most suitable for topographic or land surfaces. So for the choice of wavelength, what are the two factors that we consider? One is transparency in the medium. whatever medium it is going to travel, transparency in medium, it should be transparent. So for topographic, the medium is air, and for bathymetric the medium is water. So we should choose such a light which is transparent in air for topographic, which is near infrared, while transparent in water, which is the green wavelength. Near infrared cannot be transparent in water, it will reflect from the water itself. And the second characteristics which we use for choosing the wavelength is interaction with the surface. So it should be transparent in the medium, but it should interact with the surface, which is this. If this surface should reflect whatever wavelength we are using, so that it can go back to the LiDAR signal. Same for here at the land. So in land it is transparent in air, the NIR wavelength, but it reflects from the topographic surfaces, while for green wavelength hits the rock bottom and then goes back to the LiDAR. So that is why in bathymetric underwater terrain we use green wavelength, which follows these two criteria: transparency in medium, which is water, and interaction with the seabed or the bottom, which will give us a topographical idea. So here the transmitted laser beam, surface reflected water level, while the bottom reflected water level will tell us what is the depth, and these calculations are made up when the green light is used, which can assist in the bathymetric LiDAR system. This is an active form of remote sensing technology that uses water penetrating green wavelength to measure the depth of water bodies and map the topography of the sea floor or the riverbed. Okay, is it clear to the students? Please reply with a yes or a like. Okay. With this, we have come to the end of the presentation. So I'll just stop sharing my screen and come back to the call. Yeah. So with this, we have come to the end of this presentation. So we have solved 10 example questions from lecture week 5, where we have learned the classical surveying methods, photogrammetry and LiDAR lectures, and we have solved some of these questions. I hope everyone was able to understand, and the way of my teaching and communication, if you have any suggestions, you can give me. If you want me to make slides better, or turn on the video chat or whatever, you can suggest. But I hope it was clear to everyone, and let us have such interactive sessions. I would encourage. I apologize for being late today, but I was in a meeting and preparing for this class, but I would never miss my class. So please I would encourage all of your classmates and students to join this session next Saturday at 3 p.m. to 5 p.m. Please be on the call. This is an open call. I can join anytime, and we will have close to 1.5 hours of lecture or classes, and hope to clear all your doubts so that you guys do well in this course of forests and their management. Okay, if you have no more doubts, and please feel free to post your suggestions. This recorded lecture will be uploaded on YouTube, which will be accessible to you guys through the NPTEL, and the slides that I have shared with you guys, or I have shown in the presentation, will also be shared to you guys. Okay, so with that, let me end my call. Bye bye, and have a happy weekend. Let us meet next Saturday with lecture week 6. Thank you for joining.